Welcome to this presentation on metamodels and technologies. Using Enterprise Architect and the Sparks modeling platform, you will learn about some of the tools and facilities available to administrators, librarians, and metamodelers to use and configure system technologies, and to create your own industry, organization, discipline, or team technologies. You develop and review the profiles and technologies collaboratively. You can share them with customers and a range of other disciplines from business analysts, enterprise and solution architects, and any other interested stakeholders. In this presentation, we will cover the following topics. Get an overview of metamodels and technologies. Understand the technology lifecycle. View user-defined metamodel and profile examples. View advanced profile and technology features. Collaborate and visualize with WebEA and Prolaborate. Understand profiles and technologies and extend the tool to fit your modeling needs. A model-driven generation technology (MDG) is a mechanism for providing access to the resources of either a commercially available technology, such as frameworks or modeling languages, tool-specific features, or to a technology that you have created yourself to model organization or industry-specific notions. You can configure the tool to use any number of technologies and restrict groups of users to particular MDGs. This mechanism extends the tool and allows you to combine elements from various industries and disciplines in the same model and its diagrams, for example, blending requirements with data models and cloud architectures. Extend the tool's functionality by enabling technologies that add support for modeling languages, frameworks, and specialized tools. Enterprise Architect itself uses the MDG technology mechanism to create a wide range of languages, including Archimate, BPMN, Strategic Modeling, SysML, and more. You can also specialize these languages using the profile system utilizing a generalization connector, thus ensuring your compliance with standards but adding industry, organization, or team metadata. Enterprise Architect provides a formidable list of tool extensions in the form of technologies. You can enable these frameworks, languages, and tools, making them available to projects and users. Each technology has a name, version, and description. The technologies can be local or remote and can be added or removed. You can reference remote technologies by a file path or a URL. You can set a technology as active, which makes it your default interface to Enterprise Architect. Organizations can create user-defined metamodels and save these as profiles. The profiles and other definitions can be baked into an MDG technology and distributed to users. The profiles support standard items and their attributes. For example, a cybersecurity architect could model a cyber attack, and use enumerations to list threat types, such as ransomware, malware, Trojan horse, and others. A metamodeler could model threat targets, and elements can use alternate shapes, colors, and styles that they can develop using the Shape script editor. Properties can use simple, enumerated, or predefined tagged value types, with rich user interface selection mechanisms. When your repository requires certain MDG technologies, a model administrator can configure the system to check that those technologies are available and active during the loading process before the model opens. This procedure ensures all users have access to the required languages and frameworks. An administrator can also set a particular technology to be automatically disabled, ensuring that users cannot use these elements, connectors, and diagrams to model. Use additional MDG technologies to extend the functionality of the tool further. Organizations and teams can purchase or get complementary model-driven generation products that are not distributed with all editions of Enterprise Architect. Some of these are complementary, and others must be purchased separately. There are technologies that integrate with the Eclipse and Visual Studio development IDEs. There is also a tool that you can use to import MS Visio diagrams and another that allows the exchange of requirements with DAWs. Many other technologies exist for architectural frameworks, such as TOGAF, the Zachman framework and the Unified Architecture Framework, and many others. Add your own metamodel and metadata to your architectural descriptions to create organization-specific elements that extend the standard languages such as Archimate and the Unified Modeling Language. Use Enterprise Architect's world-class profile and technology system to go beyond a simple metamodel, and add report templates, toolboxes, diagrams, predefined and structured properties with user interface controls such as drop-downs, spin controls, calendars, color pickers, and many more. When you create a profile, you can extend elements and connectors in the Unified Modeling Language. Enterprise Architect itself uses this mechanism to create a wide range of languages, including Archimate, BPMN, SysML, and more. You can also specialize these languages using the profile system, utilizing a generalization connector. A safety engineering organization could extend the system's modeling language by adding industry-specific elements and connectors. Another organization could create profiles that extend and combine elements from two existing languages. Understand the technology lifecycle. In this topic, you will see the steps in creating robust and flexible profiles and technologies to implement your metamodel. By the end of the topic, you will have seen benefits, including: learn the steps in the technology creation process. Get a flying start with basic MDG builder patterns. Achieve productivity gains with the profile helpers. Create, embellish, and deploy your technology. And more. The process of creating a basic technology of your own is straightforward, and made easier by profile helpers, and a wizard to assemble the final technology into a distributable XML file that you can import into a production repository. Once you have created stereotypes, added tagged values, and defined toolbox and diagram profiles, you can start assembling the technology, export the profiles, and use the generation wizard to create the technology, and then import it into your test and production repositories. You can update the technology at any time and synchronize existing elements with the revised tags. Get off to a flying start by automatically injecting elements and diagrams into your repository, using the Model Wizard patterns. Browse the extensive pattern library, which contains patterns for creating metamodel profiles and technologies, including the MDG Technology Builder, Starter, and Basic patterns. Peruse the documentation accompanying each pattern to understand the benefit it will bring, and how best to work with it. Switch perspectives and gain access to hundreds of other helpful patterns, including strategic, requirements, analysis, information, user experience, and model publishing patterns. Get productivity gains with profile helper wizards to create elements and tagged values, connectors, toolboxes, and diagrams. The wizards step you through the creation and configuration of each item type, and prompt you for tagged values, which the system converts to user-defined properties in the imported technology. You can use the helpers to create new items or to edit existing ones, greatly simplifying the process of working with the profiles. Alternate images and element and connector shapes can be defined using the Shape Script Editor, allowing you to configure the graphical presentation of the elements and connectors. Elements have system properties such as status, author, and priority. However, adding user-defined attributes adds richness to an element or relationship and provides the basis for sophisticated reports and visualizations. Most disciplines, such as enterprise architecture, business analysis, and systems engineering, and industries, such as insurance, banking, travel, gaming, and others, will have specific metadata. A modeler can include this metadata as tagged values on any element, connector, or feature. The tool provides simple user interface controls for a user to input, select, and update the properties. Organizations create metamodels to ensure authors follow a recipe or template when creating diagrams. A model can be thought of as a mathematical graph of elements and relationships. You can restrict the connectors a user can select between any two elements by using a stereotyped relationship, and assigning the name of the connector stereotype. When a model administrator or librarian deploys the technology, and a modeler uses the quick linker, this will be the only relationship available to the user, thus enforcing the metamodel rules and ensuring consistency. Seamlessly generate your technology using the MDG Technology Wizard, a productivity tool that simplifies the process of assembling the technology file. The wizard steps the meta-modeler through a series of pages that form the basis of the assembly. The first page allows the user to select or reuse a manifest file which stores the information entered in the wizard page for future technology generations. The following pages ask the user to choose the stereotype, diagram, and toolbox profiles. Subsequent pages request details of any other items selected for assembly. Organizations need flexibility when deploying a technology, particularly in an era where digital workforces are geographically dispersed and often work in different time zones or remotely. An administrator or librarian can generate a technology to an XML file, which they can import into a development, test, or production repository. The generated file contains all the stereotype, diagram, toolbox profiles, and other resources, including patterns, workspace layouts, code types, modules, reporting templates, and more. A librarian uses the MDG technology wizard to generate the technology file, which they can then import into multiple repositories for the current user or all model users. Once an administrator or librarian has imported the technology into your repository, you can commence using it. Start by setting up a custom perspective that contains the technology file and switch to that perspective. If a diagram profile has been defined, you can create a new diagram and use the custom toolbox to add elements and connectors. When you select an element or connector in the diagram or the browser, you will see a group for your technology in the element panel of the Properties window. You can edit or select values for the properties in the list using the handy user interface widgets. Visualize enterprise and desktop applications and gain powerful and revealing insights into their strategic and tactical importance, complexity, and cost. These expressive diagrams will appeal to business and technical stakeholders who need to manage application portfolios and ensure they provide a return on investment, and demonstrate tangible value to the business. An organization is advised to design, create, and test a metamodel thoroughly before implementing it. This ensures that a production repository can be created without the variable of a changing metamodel. There will however be circumstances, such as a change in business or technology directions, that will mean you will need to revise the metamodel and the associated profiles and technology. Enterprise Architect has a handy device called Synchronize Stereotype for updating existing elements that are stereotyped to a prior technology. This mechanism detects elements that are not using the current technology and allows a librarian to choose to selectively update individual element tagged values. View user-defined metamodel and profile examples. In this topic, you will see how to apply the profile and technology facilities to various industries and discipline models. By the end of the topic, you will have seen benefits, including create safety engineering profiles, create cyber security technologies, create insurance and hospital profiles, create enterprise and solution architecture profiles, and more. Organizations can create industry-specific and discipline-aligned metamodels to support standard items and their attributes. For example, a safety engineering company could create elements such as hazards or failure modes and define attributes such as probability, severity, and exposure. Properties can use simple, enumerated, or predefined tagged value types with rich user interface selection mechanisms. There are over 20 types of inputs and selectors, including checklists, color pickers, diagram selectors, operating system files and directory selectors, spin controls, enumerated lists, date and time selectors, and more. The world we live in is increasingly vulnerable to digital attacks, and the discipline of cybersecurity has become an essential vanguard in protecting digital assets, including data and systems. The cybersecurity example shows how profiles can be used to define necessary metadata for a cyber attack element. Two key properties of a cyber attack, namely, the cyber attack target and the attack type, have been added as tagged values. These are supported by enumerations that, when implemented, will allow a modeler to create an element to model a specific type of attack that can be selected from a drop-down list. In this safety engineering example, the meta-modeler needed to create a mechanism for users to select multiple values from a drop-down list. While this is not possible using a simple element enumeration, it is possible using one of more than 20 tagged value types to find as a reference to a list of unique elements. When the technology is deployed, and the user selects the effect property for a failure mode, they will be presented with a window to browse and select multiple effects. In this hospital model, the user has defined several properties for hospitals, including an enumerated list of hospital types and teaching hospital designations. When displayed in the user's model, the enumerations use a drop-down list that ensures the user selects a valid value. The metamodeler has included an unspecified choice in the enumerations and set this as the default value. The operational date uses a date selector to assist the user. The author has also used an alternate image for the hospital and elected to display the tagged values beside the image. In this insurance industry metamodel, the author has defined a connector stereotype named claim against, which is the only allowable relationship between a claim and a policy. A metamodeler can define connector stereotypes that specify the relationship between two elements in the model. They can then restrict the connectors a user can select between any two elements by using a stereotyped relationship, and assigning the name of the connector stereotype. A tagged value has also been added to the connector, which specifies a property of the relationship between the two elements. Enterprise architecture is a discipline that steers an organization through an ever-changing business and digital environment. The de facto language representation is the Archi-Mate language, which doesn't allow an architect to add metadata to elements or connectors in its base form. You can, however, specialize the language with organization-specific metadata, which a modeler can use to facilitate visualizations and architectural analysis. For example, a requirement could contain attributes such as business criticality and volatility, and you could define a stakeholder type as internal or external. Organizations engage solution architects to create a high-level design before developers start working on a project's implementation. This ensures an architecture meets all the critical business and technical requirements. You can devise a metamodel to support the essential elements of a solution architecture, such as application services, interfaces, and application components. The components can contain properties such as strategic and security classes, business and technical owners, upfront and annual costs, operational and sunset dates, and more. View advanced profile and technology facilities. In this topic, you will see how to get the most out of this extensible facility and view some of the advanced metamodeling features. By the end of the topic, you will have seen benefits, including get expert technology guidance, set element geometry, change an item's appearance with shape scripts, add user-defined model wizard patterns, and more. Individuals and teams often need expert help when working with unfamiliar or advanced features of the tool. Guidances provide a handy resource comprising clear steps for completing a task, such as adding relationship restrictions and other metamodeling tasks. The guidances are available from a panel on the start page, and a modeler can conveniently inject them into their models, and then use the checkboxes to ensure they have completed all steps. The guidances will be a welcomed aid for both novice and expert users, ensuring they use the tool to its full potential. Provide users with an easy way to input and select data. Tagged values are part of the Unified Modeling Language Extension Mechanism. An enterprise architect provides a rich set of predefined structured types to support tagged values. A metamodeler can use these types to define diagram, element, connector, and feature properties, including complex types. Enterprise Architect provides a rich and convenient set of user interface controls that modelers use to input or select values for defined properties. For example, there is a date calendar picker, a drop-down list, a spin control, a color picker, a checklist, a progress bar, and many more. Using an enumeration, a metamodeler can add enterprise reference data to a tagged value. The reference data is available to a stereotyped element as a drop-down list. The reference data is the master, and changes to the master list will be immediately available to any element using the reference data in a tag. Reference data includes statuses, constraints, difficulties, priorities, requirements, risk types, and more. An MDG technology behaves as a container for a range of modeling items. The notion of stereotyped elements and connectors and their tagged values are defined in the profile definition of the Unified Modeling Language. Enterprise Architect includes the toolbox and diagram profiles that allow the items to be used within a modeling context. In addition to the profiles, the tool includes a number of modeling artifacts, including images, scripts, workspace layouts, reports, transforms, model patterns, views, and searches, bundling them into the generated technology file. Change the appearance of elements and connectors with shape scripts. Use this flexible and effective mechanism to delight your users with representations that are meaningful to them, and resemble items in their industry or domain. The scripts are used to override the base unified modeling language presentations. You create a shape script in a dedicated scripting language to define an element or connector's new shape, orientation, color, and labeling. Each script is associated with a stereotype, and every element or connector with that stereotype will adopt the appearance defined by the shape script. You can specify the dimensions of a newly created element by setting its default height y value and width x value. This can be a useful mechanism when an element has its text compartment visible, or there are wider than normal properties or values. A modeler may also want to mimic an element's shape in a standard or comply with a user's preference for an element's geometry. When you generate the technology, you must indicate that element sizes are to be honored. Add images, layouts, and scripts to embellish your technologies and give your users access to these useful facilities. A meta-modeler can add images from the image manager, and they are a welcome substitute for the language rectangular shapes of the modeling languages. Workspaces provide a set of windows and tools that are designed to work together for a given discipline or task, such as conceptual data modeling. Scripts help perform repetitive or complex tasks and can be used for various purposes, such as refactoring models and diagrams, updating multiple elements, locating elements and diagrams, and more. Add rigor to your team's modeling discipline by enshrining model content and structures into a model wizard pattern. Define model content, including packages, elements, connectors, and diagrams, and allow your users to inject this content into their production models. This could be packaged content such as the structure for new projects or an organization-specific diagram. You can add guidance information by creating a wizard pattern document containing helpful hyperlinks. Collaborate and visualize with WebEA and Prolaborate. In this topic, you will see how to bring your models to life and share them with the broader community of users in a web browser. By the end of the topic, you will have seen benefits, including collaborate, discuss, chat, review, share, and mail teams. View models on the go from any device, anywhere. View and update models in WebEA and Prolaborate. Visualize models with Prolaborate dashboard widgets. And more. Put architecture in your pocket, and instantly view real-time models in a browser no matter where you are. View the models on a notebook, tablet, or smartphone, and create new requirements, application components, and more, adding notes and other details as required. Collaborate with colleagues, consultants, and customers by entering into discussions, chat, reviews, and viewing each other's model additions and changes, in real time. Organizations benefit from individuals working as a team, and being able to collaborate. This collaboration is critical when designing a metamodel and technology that will underpin your enterprise and project models. Work on the profiles and technologies as a team, as though you and your colleagues were in the same room solving problems together. Enterprise Architect has a formidable set of collaboration tools, including discussions, chat, reviews, calendars, libraries, and more. Update properties in WebEA and disseminate your modeled information by making it available in a browser using this lightweight but handy tool. Using WebEA, you can search for elements and diagrams and view and update properties such as an element's tagged values. The same user interface controls provide a simple mechanism to select, input, or change element and connector properties. There are input boxes, drop-down lists, spin controls, date and color pickers, and windows to select another model element, such as a business owner, and more. Prolaborate users can select an element in a diagram, chart, list, table, or other visualization, and display both the standard properties and the tagged values. Model authors can edit the tagged values using the same user interface controls available in Enterprise Architect and WebEA. The tool has a flexible access control system and form designer that can selectively display properties, based on users' and groups' roles and permissions, thus hiding irrelevant or restricted properties. This mechanism paves the way for federated updates and decentralized management of repository information. Visualize enterprise and desktop applications and gain powerful and revealing insights into their strategic and tactical importance, complexity, and cost. These expressive diagrams will appeal to business and technical stakeholders who need to manage application portfolios and ensure they provide a return on investment, and demonstrate tangible value to the business. Drill down through multiple dimensions with sunburst charts that allow you to quickly invert dimensions, such as programs, projects, and strategic, tactical, and obsolete application groups. Unlock the wealth of information in the repository, and serve it to corporate stakeholders and executives in compelling and interactive charts. You can change report settings such as colors and styles to align with your organization's conventions. Survey your capability landscape, and create compelling diagrams that model capability hierarchies, and drill down to reveal the underlying metadata associated with each capability. In this presentation, we have covered the following topics. Get an overview of metamodels and technologies. Understand the technology lifecycle. View user-defined metamodel and profile examples. View advanced profile and technology features. Collaborate and visualize with WebEA and Prolaborate.